Hello.
हाँ भैया.
Yes.
Yeah, we can start because we can record now only. After that we will upload it. We can start now. I think so. There are more than 51 people are there. So we can start.
Okay भैया. Mathematics compares the most diverse phenomena and discovers a secret analogies that unites them. Good morning to all over this virtual platform. This is Gayatri, and I welcome you on the day 3, session 1 of the 5-day National Mathematics webinar event organized by Tripura Mathematical Association on the occasion of National Mathematics Day 2021. Now we have the invited talk by Dr. Biruji Dasa from National Institute of Technology Warangal in this first session. Sir is an ad-hoc faculty in the Department of Mathematics at NIT Warangal. Sir is an MSc Gold Medalist in the Mathematics from NIT Agartala. Sir has completed his PhD in Uncertain Sequence Spaces in 2021 from NIT Agartala. Sir has an areas of research interest in uncertainty theory, sequence space, fuzzy mathematics, topology, and its generalized structures. Sir is also qualified UGC CSIR NET in 2016, SLET from Northeastern Region in 2018, and twice in GATE in 2015 and 2016. Sir has also awarded Dr. B.R. Ambedkar Award, Memorial Award by the State Government Tripura twice in the year 2009 and 2010. Sir has published a total number of 24 research papers, out of which 7 are published from SCIE Index General, 13 from Scopus Index General. Sir is also the life member of IMS, ISCA. Sir has also attended numerous number of national and international conferences, out of which 3 research papers were awarded as the best papers. Sir is currently working in collaboration with renowned researchers from Turkey and Colombia in the field of fuzzy topology spaces. The title of today's talk is A Study on Sequence and Series and Research Relevance on Uncertainty via Uncertainty. Welcome you, sir, in this virtual platform. Over to you, sir.
Am I audible?
Yes, sir, you're
Yeah.
audible.
So thank you very much to the organizing committee of Tripura Mathematical Association. I congratulate you for organizing such a program on National Mathematics Day. So I wish you all the best. So today I will be the organizers requested me for taking a talk of 1 hour. So I could not give you this much of time because of some administrative work there is on 11:45 I think. So I prepared some slides and it will be taking roughly around 30 minutes like that. So I will be starting right away. So the title of the today's talk is a study on sequence, series, and research relevance via uncertainty. Recently, the theory of uncertainty has been applied to various fields of mathematics, and researchers are doing great works in uh, the field of uncertainty theory. And in the BSc, students are already aware of this topic, sequence series. And my research broad area was also uncertain sequence spaces. So I thought that I will be delivering a lecture on basics of sequence and series, which we studied in BSc mathematics, and uh, gave you some idea how the study of uncertainty theory has been applied in sequence and then series. And normally in BSc or in class 12 also, whatever sequence and series we have studied, those are only single sequences, and there are also lots of works available in the literature on double sequences, triple sequences, or multiple sequences. like this are available there. So I will be giving some idea of double sequences in the talk also. So starting with sequence, what is a sequence? So we have studied like this way. If we consider a set like this, suppose first element is 1, then 3, then 5, then 7, in this way. So we can call it a sequence of numbers. A sequence of numbers. Now some may say that there is a pattern in this sequence, that first element is 1 and then we are going in an arithmetic progression with the gap at 2. The distance between each point, each consecutive points is 2. So it is not required that there will be some pattern. Suppose first element 1, then 2, then again 7, then -5. In this way we can also go. So this is an example of a sequence of numbers. Now, what is a formal definition of a sequence? So try to count the numbers of this set. So we will assign, say this is the first element, this is second element, this is third element, this is fourth element. So we can see that there is a mapping 1, 2 in this way, and to 1 we are assigning the element 1, to 2 we are assigning the element 2, to 3 we are assigning the element 7. So in this way we can say that a sequence is a mapping whose domain is the set of natural numbers, from natural number to the set of real numbers. So this sequence is called a real sequence. So a real sequence is nothing but a mapping from the set of natural numbers to the set of real numbers. So this is the formal sequence, formal definition of real sequences. Now there are different types of sequences: convergent sequence, divergent sequence, oscillatory sequence, then bounded sequence. In bounded sequence there are two types of sequences are there: bounded above and bounded below, and then comes unbounded sequences. So I will be giving some concepts on those sequences later. Now what I have seen there, that a sequence is a set. A sequence is itself a set in this way. This is a sequence, but it is also a set also. So what is the difference between a sequence and a set? This is an interesting question, but the answer is very easy. What is the difference between a set and a sequence? Now, the answer of this question lies in the very definition of this sequence, real sequence. So what was the definition? Definition was that mapping from N to R. Now, mapping from N to R, now there are infinite numbers of elements in the set of natural numbers. So the corresponding number of entries will be infinite. So we can say that a real sequence always contains infinite number of points, but in case of set it may be finite or it may be infinite. So there is a difference between set and sequence. Now there is one more difference between set and sequence. So we see that sequence is infinite set, is a infinite set. A sequence is an infinite set. So infinite set, there are two types of infinite set. Anyone? There are two types of infinite set.
Countable and uncountable.
Yes, countable and uncountable. So what do you think? A real sequence falls under which category? Countable or uncountable?
Countable.
Countable, because countable infinite set, its definition is the similar of that real sequence. A countable infinite set is a mapping from natural number to real number, and uncountable we cannot count it. Like an example is the set of real number itself is uncountable, and countable the set of natural number is a countable set. So we see the difference between a set and a sequence in this way. Set may be finite, but sequence is always infinite. And set may be uncountable, but a sequence is always countable. Now going to the next topic, which is convergent and divergent sequence. Convergent and divergent sequence. So I will be starting with examples only, because maximum of you are doing graduation, and in graduation, till graduation we have studied the concept of sequences in class 12 only, and there were no concept of convergence and divergence there. Only we have dealt with examples of sequences. So first of all, I will try to explain the convergence sequence by example, and then we'll give a formal definition which will be easily understandable. So suppose I am taking a sequence 1, 2, 3, 4 in that way. So the first term is 1, the second term is 2, the third term is 3. So by this pattern, we see that the nth term is n. The n plus 1 term is n plus 1. So what is the infinite term? It will be infinity. Now we cannot say anything like t infinity, because where is infinity we do not know. So we can say that this sequence is going towards infinity. So it is not converging to any finite point, we can say. Suppose there is a sequence 1, 4, 9, 16 in this way. So the nth term an can be written as n square. Now if the term number which is n, term number is going to infinity, then we see that n is also going towards infinity, because if n goes to infinity, n square will be going automatically towards infinity. So again we see that it is not converging to any point. So in this way we can understand the concept of convergence. Suppose again we are taking an example of sequence, say first term is 1, second term is 1 by 2, third term is 1 by 3, and that way we are going. So we see that the nth term is 1 by n. The n plus 1 term is 1 by n plus 1. So the behavior of the sequence is that after going the rightwards, we see that each of the elements are decreasing. 1 by 3 is less than 1 by 2, 1 by 4 is less than 1 by 3 in this way. And all the elements are actually greater than 0. So all the elements are positive, but they are decreasing. So obviously we can say that term going towards 0 only. Going towards 0 only. So in this way we can say that this sequence is converging, and converging towards which point? Converging towards 0. So these are the examples which are easily understandable. Now from that example we will deduce, actually we deduce example from definition. Now for easy understanding we will deduce the definition from example. So what we see that in this particular example, we see that the difference between the difference between second term and first term is half. Again, we see that the difference between third term and second term is 1/6. The difference between the next two terms, F4 and F3, is 1/12. So what is the pattern here? Anyone? F5 minus F4 is equal to 1/5 minus 1/4 equal to 1/20. So what is the pattern? Half is greater than 1/6. 1/6 is greater than 1/12. 1/12 is greater than 1/20. So we see that the difference between two consecutive numbers, an and an plus 1, is decreasing. When we are going rightwards, and when we are going towards infinity, we see that this difference tends to 0, because the difference is decreasing and the difference is positive, so it is going towards 0. So if you take, suppose you are taking a positive number, suppose you are taking epsilon. This is positive number. Suppose this is 0.01. Epsilon is equal to this. So we see that there are numbers 1/99, 1/100, 1/101 in this way, and we see that starting from the 101st element, if you take any number, suppose the first number we are taking 1/101 minus that limiting value. What I said, the limiting value was 0. So if you take the difference between these become 101, which is less than that 0.01, that epsilon. If you take any number, suppose 1/102 minus 0 is equal to 1/02, this is less than epsilon. So for any number n greater than 100, we see that 1/n minus 0 less than epsilon. So we suppose this is capital N. So the formal definition of convergent sequence will be, if there is a sequence n, like first term is A1, second term is A2, in this way. So this sequence is said to be convergent to a fixed number, say L. So the sequence is converging towards L if for any epsilon greater than 0, we can find certain natural number n such that the difference between the numbers of the sequence and the fixed limit L, this less than epsilon for all n greater than capital N. What we have seen in the case of the previous examples. Here L was 0 and n was 100, epsilon was 0.01.
Sir, can you please repeat it?
We have actually the difference between, see, the first element was 1, second element was, suppose here 0 was here and 1 was there. 1. So our first element was 1, second element was half, third element was 1 by 3, then 1 by 4. So what we have seen? We have seen that that sequence is coming towards 0. Now we have taken epsilon is equal to 0.01. So for that epsilon, we see that from 100th element, starting from 100th element, the difference between those elements of sequence and that limiting value 0, this difference becomes very less than epsilon also. So if this condition is satisfied, then we can say that the sequence is convergent. After a certain period or certain number of elements, all the difference between the fixed limit and the sequential elements are less than that given number, epsilon. If this condition is satisfied, then we say that the sequence is convergent. Or in easy way, we can say that the difference between the sequential number and the limiting point is very less after a certain period. Because if it is not less than that given number, then we cannot be sure that it is going towards a certain point or not. This is the analytical way to define a sequence, convergent sequence. And for calculation purpose, just we have to find the limiting value of the nth term. If this is exist finitely, this is easier to understand. A1, A2, A3, in this way we are going. So if A infinity exists, then obviously we say that this sequence is converging towards a fixed point. So that is why we will be finding the limiting value of n when n tends to infinity. And if this exists finitely, then we say that the sequence is convergent. And if it does not exist, then we say that it is not convergent. That means divergent. Now consider this sequence only. Here an was 1 by n. So what is the limiting value? Limiting value is 1 by infinity, that is 0. So that means the sequence is converging towards 0. Now, if we have considered this sequence 1, 2, 3, 4 in this way. So here an was n. So limit an is equal to limit n equal to infinity. So not finite. So that means not converging. Okay. Suppose we are considering another example, sequence an, where an is given by n plus 1. N by n plus 1. So what is the first term? First term is 1 by 2. Second term is 2 by 3. Third term is 3 by 4. In this way we are going. So see, here, seeing this sequence, what we see? That first term is half and the sequential elements are increasing or decreasing?
Increasing.
Increasing. But it never crosses 1. All the elements are less than 1. So the common sense says that this sequence increasing and it always less than 1. So the limiting value will be 1. Or the sequence will be said to be convergent to 1. What does the calculation says? Limit n tends to infinity n is equal to limit n tends to infinity n by n plus 1 equal to limit n tends to infinity dividing both parts by n. So putting 1 by 1 equal to 1. So this is converging towards 1. From the concept of limit. Understood?
Yes, sir.
So in this way, convergent and divergent sequence, if a sequence does not satisfy this condition, that means if a sequence is not convergent, then it will be called divergent. Now, what is oscillatory sequence? Now we have seen that whatever I have discussed, we got the idea that if a sequence is converging, then it means that n tends to a finite limit L as n tends to infinity. And for divergent, we have seen n tends to infinity, or it might tends to minus infinity as n tends to infinity. There is a case for some sequences when this condition is not satisfying. That means n is not going towards a finite value, and also this condition are also not true. That means it is not approaching infinity also, and it is not approaching minus infinity also. So anyone, any example? From graduation student I am asking.
minus 1 की power n.
minus 1 whole to the power n.
Okay, suppose we are taking a sequence 1, first term is 1, second term is 0, third term is 1, fourth term is 0, fifth term is 1, sixth term is 0, in this way. So there is a pattern. In odd number of places, there is always 1, and in even number of places, there is always 0. So we can say that this sequence is an, where an equal to 1 if n is odd and 0 if n is even. So it is not going towards infinity. It is either going towards 1 or going towards 0. Now what is limit n tends to infinity n? Anyone? It actually does not exist, because where n is going towards infinity, it is odd or even, we are not sure. So the value will be 1 or 0. This is not defined actually in this case. So the limiting value does not exist for this case. So this sequence is not convergent. This sequence actually a divergent one. Now there is a debate between these two concepts that it will be called divergent or not. But since that in the definition we have said if a sequence is not convergent, it is called divergent. So in that approach we can say that this sequence is divergent. Now we have seen that here the elements of the sequences are oscillating between two numbers 1 and 0. First 1, then it oscillates and goes to 0, then again 1, then again 0. So for that case we call them as oscillatory sequence. So there is another example you have mentioned, n is equal to minus 1 to the power n. So first element will be minus 1, second will be 1, third minus 1, in this way. This is also an example of oscillatory sequence. Then concept comes bounded sequence. So there are two types of sequences, bounded or unbounded. In boundedness, there are two types of boundedness, bounded above and bounded below. So for obvious reasons, from the name of this sequence, bounded above sequence, you have the idea that if the sequential numbers n, each element less than some finite number k, then the sequence will be said bounded above, because it does not crosses that big number k. So one example will be 1/2, 1/3, 1/4, in that way. So all the elements we here see that an is less than, suppose 1.5. Here k is equal to taking 1.5. Some may say k is equal to 2. So this condition is satisfied. N less than k for all n belongs to n. So we say that this sequence is bounded above. And if a sequence is greater than some L for all n belongs to n, then we say that the sequence is bounded below. This set itself is bounded below because all the elements we see that are greater than 0. Here all the elements are greater than 0, so we take L is equal to 0. One may say that L is equal to minus 1. So yes, n greater than minus 1. For all the elements. So we see that this sequence is bounded above and bounded below 2. There is a sequence. Anyone can give an example which is bounded above but not bounded below?
So 1 by n.
1 by n is bounded above also and bounded below also.
Sir, minus n.
Minus n. An is equal to minus n, you are saying. So first element is -1, second element is -2, third element is -3 in that way. So we see that all the elements are actually less than 0. So taking k is equal to 0, we see that this sequence is bounded above. And the lowest element we cannot determine because an is going towards -infinity. So we cannot find any number such that all an is greater than L. So this sequence is not bounded below, it is bounded above. And obviously if you take an is equal to n, then it becomes bounded below but not above. So we know the concept of bounded above and bounded below. Now when a sequence is said to be bounded, simply bounded, the definition says that if a sequence is both bounded above and below, then that sequence will be called bounded. So suppose in this case L less than An less than K, in this way, there will be some lower bound, there will be some upper bound. So if we consider maximum of L and M, suppose it is maximum of L and M, suppose M is the maximum value, L and K, so suppose K is the maximum value. So we can write from here K greater than L, that means minus K less than L. So minus K less than L less than An less than K. So from here we can write minus K less than An less than K. From that we can write mod An less than K. So this is the formal definition of bounded sequence. For bounded above, An less than K. For bounded below, An greater than L. But for boundedness, An mod N less than some P, suppose, which is the maximum of K and L. Mod N less than P. So this is the formal definition for bounded sequence, and three types of bounded above, An less than K, bounded below, An greater than K, and for simply bounded, mod N less than M. Now a sequence is not bounded, which is not bounded, is called unbounded. Now there is an important theorem, very important theorem, that every convergent sequence is bounded, but the convergence is not true. I am taking very much time. Every convergent sequence is bounded. Every convergent sequence means it is bounded. You can see, take any convergent sequence, you will see that it is bounded actually. There will be one lower bound, there will be an upper bound. But the converse may not be true. Suppose we are taking that -1, 0, -1, 0, -1, 0. In that way going. So this sequence is bounded because it is less than, all the elements are less than 1 and all the elements are greater than -2. So this sequence is bounded, but it is not converging to a finite limit. It is oscillatory. Understood? And from the definition of every convergent sequence is bounded, you will find it. The definition of convergent sequence was mod An minus L less than epsilon. So if we this way, minus epsilon less than An minus L less than epsilon. So L minus epsilon less than An less than L plus epsilon. So we see that the sequential terms are less than L plus epsilon and greater than L minus epsilon whenever N greater than N. So in that example, starting from the 101th element, all the elements lies between 0 plus 0.01 and 0 minus 0.01. So all the elements starting from 100 1, 102, we see that this lies between minus 0.01 and plus 0.01. So all the elements are bounded, starting from 101, 102 to this. And when starting from A1, A2 to A100, we obviously see that these elements are finite. 1, 1 by 2, then 1 by 100. This is also bounded. So from first element to 100 element, we see that this is bounded, and starting from 100 first element to the infinite elements, we see that this is bounded. So we can say that the whole sequence 1, 1 by 2, 1 by 3 is also bounded. So every convergent sequence is bounded, but the converse is not true. So now we come to the concept of double sequence. What is double sequence? So suppose we denoted the single sequence by an. Now in case of double sequence, we will be denoting it by amn. So first element will be a11, not a11, 11, then a12, a13. In this way we will be going, and then starting from a21, a22, in this way the elements will be going. So suppose we have defined a double sequence amn by amn equal to n if m is equal to 1, m if n is equal to 1, and 1 by mn if m greater than 1, n greater than 1. So what will be the sequence? We will be starting from here. So the first element is a11. So a11 will be 1. a12. So this comes under this because this one is 1. So this is n, means 2. Then a13. So this comes under again this condition. So this will become 3, 4. In this way, this row will go. Now what is a21? Here m is 2, n is 1. So n is 1 comes under this. So the value will be m. That means 2. Then a22. A22, this comes under this. So 1 by 2 into 2 means 4. Then comes a23. It comes under this 1 by 6. Then 24, 1 by 8. In this way it will go. Then the third term, a31. 31 comes under this. So it will be 3. Then 1 by 6, 1 by 9, 1 by 12. This way. And 4, then 4 into 2, 1 by 8, 4 into 3, 1 by 12, 4 into 4, 1 by 16, in this way. So in this way, the sequence will go, double sequence will go. Now, you can see that the first row is going towards infinity. The first column, it is going towards infinity. So you may say that the double sequence is not converging, But if we exclude these finite numbers of row, that means first row and first column from this double sequence, and see the remaining ones. Now go through this row, 1 by 4, 1 by 6, 1 by 8, it is going to 0. This is also going to 0. If you go column wise, this is going to 0, this is going to 0, this is going to 0. Now the definition of double convergence concept, convergence of double sequence concept says that if you exclude some finite numbers of row and finite numbers of columns from the double sequence, and then if you see that the elements are going towards a finite number, here it was 0, then we see that this double sequence is converging. Now one very important difference between the convergence of single sequence and convergence of double sequence is that we have seen that convergent single sequence always implies it is bounded, but convergence of double sequence does not implies it is bounded. You can see this example only. This double sequence is converging to 0, but it is not bounded because the terms, some terms are going towards infinity also. So okay, I did not get any time for studying this infinite series. Actually, there will be convergent series and divergent series, and divergent series is very much important for the research purpose. And since it is the webinar is on Ramanujan's day, so celebrating the birthday of Ramanujan. So if you go towards his life history, you can see that he have worked with Professor Hardy, then Professor Littlehood.
Yes,
You may
sir.
have heard their name. So they have done many works on divergent series actually. That's why I have chosen this concept. Uh, some of you in social media may see that this is a divergent series. 1 plus 1 minus 1 plus 1 minus 1 plus 1. So this is a divergent series actually. But if you consider these two terms in this way, so we see that 1 minus 1 is 0, then 1 minus 1 is 0, then 1 minus 1 is 0. So in this way we can say that this is this is summable, this series is summable to 0. So how it is becoming divergent? Or one may say that in this way, 1 minus 1 plus 1 minus 1 plus 1 in this way. So 1, take minus 1 from this common, 1 minus 1, then again minus 1 minus 1, again 1 minus 1. In this way we are going. So 1 minus 1 is 0, minus 1 minus 1 is 0, minus 1 minus 1 is 0. So in this way we see that this is summable to 1. So in one approach it is summing to 0, in one approach is summing to 1. Again, there is another concept. Let S is equal to 1 minus 1 plus 1, 1 minus 1 plus 1 in this way. So what is 1 minus S? So 1 minus S means 1 minus, put the value of S. Put the value of S, 1 minus 1 plus 1 minus 1 plus 1. So if you calculate 1 minus 1 plus 1 minus 1 plus 1 minus dot dot dot. So this is becomes S only. So we have found 1 minus S is equal to S. So 2S is equal to 1. So S is equal to half. So this S is equal to half. In this approach, we can find the value of S is equal to half. So Hardy worked on this type of sequences and his works are very much commendable. There is a book of Hardy's, which is one of the most famous book of mathematics, you can say, Divergent series.
So this series means not fixed value.
No. This series is divergent, but this is a different approach. Different approach to see what is the sum. But there are various problems in these approaches. These are discussed in this book, Divergent series. Divergent series by Hardy. Okay. So if you have seen the movie on Ramanujan, you will be seeing that the presence of Hardy and the presence of Professor Littlehood were very much there, and there were lots of works done by Ramanujan also in a divergent series, infinite divergent series also. So the research relevance by uncertainty, I could not discuss it, but I will be recommending the book by Professor Bordinglew, but I think people won't understand many much from this book, Uncertainty Theory.
So can you share the PPT to our participants, those who have registered for?
I will be sharing this PPT, and also I will be sharing the book of Divergent series by Hardy. So I recommend each of the students to go through at least the first chapter of this book, Divergent series, and the preface written by Professor Hardy and Professor Littlehood. Preface of the books you will be getting motivated to learn the uncertainty series, thus infinite series and infinite sequence also. So I thank once again to the organizers of Tripura Mathematical Association for conducting a webinar on this special occasion. So thank you very much to the presenters, but to the participants here, and also the organizing committee for organizing such a program. Thank you very much.
Thank you, sir. Thank you so much. Actually, it's our pleasure to have you here with us. And despite from the knowledge of mathematics, you have also given us the inspiration that age doesn't matter, and whether